So last time in class we spent a lot of time getting here when we were talking about logistic regression. So all of these machine learning algorithms are about minimizing some kind of error function or finding the weights that minimize some kind of error function. So this is what we have to minimize in order to solve the logistic regression problem. And so the way you do this is to set the gradient equal to 0 and solve. But what is the gradient? So let's try to figure out what the gradient of this thing is. So instead of just writing it down directly, let's take a couple of partial derivatives and try to figure it out. So what is the partial derivative of j with respect to, we could say w0, or should we try wi? I hope that's not gonna be too conceptually weird for anybody, but so we'll take this partial derivative. So what happens? The derivative comes past the constant, it comes inside the sum, and you take the derivative of natural log. You know, the derivative of natural log is the derivative of the inside over the inside. So we have all this stuff, we just copy it, and goes from 1 to n, and now we have this stuff on the bottom for sure. Okay, and now let's think about what goes on the top here. So it's the derivative of this. So the derivative of 1 is 0, and the derivative of e is itself. So we copy e here, yn wt xn, and now comes the part that actually depends on wi. So all of that stuff was true no matter what we were calling the variable. But how does wi work? So wi is inside this dot product here, and it's hitting two things. It's hitting yn, or negative yn, and it's also hitting xi. So what pops out is minus yn times, so wi is gone, and you get xi here. And it's actually the it's xn comma I. So this is row n, column I of the big matrix X. Okay, so that's what it is. And if you want to, you can make this a little bit nicer looking by canceling this and that on the top, by multiplying top and bottom by that amount. So let's do that. So this is the same thing as 1 over n times the sum, and we'll write minus yn xn comma I here, and now we have 1 plus e to the yn w transpose times xn. And what I've done is I've multiplied top and bottom by this. And so this is actually what happens when that quantity hits 1. When this quantity hits that, it turns into this 1. And when this quantity hits that, it turns into a 1 on the top. And that's why it's gone. Okay, so this is just the partial derivative with respect to wi. It's not yet the gradient. So the gradient, you know, is the partial with respect to w0, the partial with respect to w1, etc., 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 the partial with respect to wd. Okay. So what is that going to look like? All of this stuff, this is just a number. And here you have n going from 1 to capital N. So for this one, you know, you would have 0 for the I here. For this one, you would have 1 for the I here. And for this one, you would have D for the I. And you can represent all that stuff just by writing this as 1 over n times the sum minus yn, and now I'm going to write the vector. Okay, so now this is, the stuff in the red bubble here is a scalar, but now it's times a vector. So we're adding up this vector, a whole bunch of them from n equals 1 to capital N. So this vector quantity is the gradient of the error function for logistic regression. Now we have the problem of how, how do you minimize any function? You take its gradient and set it equal to the 0 vector and then solve. So we could set each one of these equal to 0 and then try to solve that equation for w. But instead of doing that, we're going to explore a different approach called gradient descent. So gradient descent is a general method for minimizing functions, and I'm going to do that in another video. But this is what we have. This is the gradient of j equals this, and let's just stop this for now.